You can maximize, minimize, and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Thank you for joining us on our Microsoft Virtual Training Day. Welcome to AZ 900. My name is Josh Rodriguez, and I'm a Microsoft Technical Trainer. Let me tell you, it is my honor and privilege to be teaching this course today. So in this lesson, we'll go over cloud computing, cloud models, and capital versus operational costing. If this is your first introduction to the cloud, don't worry. This is going to be great because we're going to be covering general cloud computing terminology. And these will be common terms. So regardless of the different cloud providers in the market, whether you're AWS, GCP, or Azure, the terms in this section are going to be universal. Now, a lot of people think they know about clouds, right? Some say, I'm an expert, I know everything. And some say, I know nothing, I'm a beginner. And some can tell you everything you need to know, and others are just completely lost. When I began learning about the cloud, I needed some insight. So I went and I asked one of the wisest, smartest, and most technical people I know, my 12-year-old nephew, Lucas. And I said, Lucas, my glorious nephew, what is the cloud? Lucas looked at me and, happy to share his vast wisdom, said, well, Uncle Josh, the cloud is a fantastic, wonderful place. There, the files and data from my apps and my games are stored. This way, no matter where I play my games, whether I play them at home, whether I play them at grandma's house, or even on the road, as long as I log in with my credentials, it will have my saved progress. And I said, wow, okay, didn't know you knew the word credentials, that's cool. And then I said, you know what? Let me ask the least technical person I know. And that's my sister and Lucas's mother, Gladys. So I said, Gladys, what's the cloud? And she said, well, isn't the cloud the place where all of my pictures and photos and videos go? Like when Lucas was born, I took so many pictures and videos, I filled up my phone. So now I pay extra to store all of them in the cloud. This way, no matter what happens, even if I break my phone, all of my pictures are safe in the cloud. All 263,724. And I said, okay, cool, thanks, Gladys. So when it comes to my sister and nephew, they're actually both right in their own way. Because the official definition of cloud computing is the delivery of computing services over the internet, enabling faster innovation, flexible resources, and economy of scale. Like Lucas said, the cloud is a wonderful, majestic place. Here, you're renting infrastructure. And when you are renting them, remember that compute, networking, and storage, we're renting those from a cloud provider. And one of the great things about the cloud, one of the biggest reasons why so many companies are turning to the cloud, is that it allows them to unburden themselves with things that can be considered dangerous, scary, even difficult when it comes to running a data center. Because data centers can be physically, virtually, and economically demanding. Now, when you look at these three, when you look at compute, networking, and storage, an easy way to understand them is to compare them to the human body. The computing, that's the brains of the operation, okay? That's where everything is processed. Now, networking is the limbs, right? That's where all the movement comes from. And then finally, storage Storage is the stomach. It's where we keep and retain everything. And the truth is, when it comes to technology, clouds are actually grounded, right? We're not talking about Cumulo, Nimbus, or Cirrostratus. No, that's another course that we teach. Now, there are actually data centers all over the world that are run by third-party organizations where customers and clients like yourself have access to take advantage of all of these tools. Now, previously, in order to do so, your only option was to have your own data center. Those days are long gone because now we have the cloud. Now we have flexibility. And truth be told, when most people think of the cloud, they think of large corporations, right? Significant social media apps, high-tech language and jargon, and it can be incredibly intimidating. The reality is that the cloud is incredibly accessible, and it can be as large or as small as you need it to be. The beauty of the cloud comes in its multiple benefits, be it accessibility, financial, and honestly in many other ways. Owning your own data center can be a pain. There's tons of overhead, significant costs, and a lot of maintenance that simply just doesn't exist when you rent from a cloud provider. Now remember what I said. Everything in the cloud is renting storage, computing, networking, and we can use analytic systems that are built in there as well. Well, in the public cloud, here you're hosted by a public provider. Now, these providers have enormous data centers where inside they have tons and tons and tons of hardware physically in these data centers. They'll have server racks, miles of cabling, and so much more. And they work by allowing customers and clients to rent their cloud. And they do so by connecting over the public internet. Now that's the key here, okay? They rent over the public internet. Now the cool thing about the public cloud is that it allows you to do things that otherwise would be just impossible. For example, my sister Gladys, right? She stores all of her photos online. She does it through literally the press of a button. She doesn't have a server rack or an NAS device to store those portfolios. And even if she did, where would she fit them? No. Instead, she's able to take advantage of the public cloud and its availability without having to be an expert on cloud fundamentals, like you all will be soon. Now, OneDrive is a great example and an amazing way to store not only photos, but files, documents, and so many more. OneDrive is a great service provided on a public cloud. We love analogies here. So for the public cloud, I like to think of it as taking the bus or the subway. It's public. Anyone can use it. They can hop on and hop off whenever they see fit. And typically, they pay for whatever distance they went based on their stop. Most importantly, they're not in charge of its maintenance, right? They don't have to put gas in the tank. They don't have to put air in the tires. They don't have to get one of those, amazing scented trees that smell like lavender blossoms on a warm summer day. No. There's no significant prerequisites needed to use it. In order to get on the bus, I don't need a license. Heck, you don't even know how to drive, right? And the buses are usually the most up-to-date models. You don't typically take a bus from, the 1400s. And again, with the bus or the subway, you pay based on where you got on and where you got off. You pay based on your usage. Now, many will think that private and public are polar opposites. But the truth is, they actually share a lot of the same design and technology. The private cloud is a single organization who has total control, okay? They're in charge of the hardware, all of it. Only that organization has access to those services and resources. And as a great philosopher once said, with great power comes great responsibility. And that's extremely true here. Remember that with the private cloud, you will incur high costs and overhead. And once you have your infrastructure set up, you also need to have the technical expertise to run them. Because you are doing the ordering. You are racking and stacking. And if there are issues, problems, and you need to hit that panic button, well, too bad, my friend. There isn't one. You have to fix it because you are in charge. Now, there are benefits to this. One of them is that you don't need a public connection to access your data because technically, you are the data center. You can have a completely private network in order to access this. And as a private cloud owner, remember, you're in control. And you are responsible. You get to control who, what, when, where, why, and how your data is accessed. But on the flip side, never forget, you have to fix everything. And a very easy way to remember the private cloud is to think of a simple word: control. Now, since we said the public cloud is like that bus or the subway, well, it only makes sense that the private cloud is more like your own car. Just like the bus, it transports you, right? However, you are in complete control of this car, okay? But you're also responsible for it. Yes, you can go wherever you want, but you fill up the gas, you put air in the tires, you clean up all those food wrappers that have been under the seat for more days than you care to admit. In order to drive it, you have to know how to drive. You need a license, you need insurance, you need registration. And if you get a flat tire, guess what? You change it. Oil leaking, you fix it. But you also get to decide who gets to be in that car with you. It's your car. You decide where it goes and when. You can paint it light green with, flame decals. You can go down the highway blasting music at the maximum volume because it's yours. Remember, you are in total control and you have total responsibility. So you get to decide who gets to be in that car with you and who doesn't. So we talked about the public, right? Talked about the private and how they have similar, but again, they're opposites in a way. Now you can say the public can be considered sweet, the private can be considered sour, but sometimes you need the best of both worlds. Sometimes you just want sweet and sour, and that is where the hybrid cloud comes in. The hybrid cloud allows you to take components of the public cloud while still maintaining control in the private cloud. So, let's say there's an organization like an accounting firm or a medical office, and they have a public-facing website. That website needs to be light and fast. It needs to be easily accessible and, more importantly, easy to use and easy to edit. That would be a great way to use the public cloud because that public cloud provider would allow them to host their servers. But let's say due to, HIPAA standards, data governance, or, all the other stipulations that are out there, they have to have that website connected to a secure database that they have to maintain control over. Well, they now have the flexibility to have the benefits of the public cloud as well as maintain control with the private cloud. Another great example is a service that we'll talk about in depth later called Azure Active Directory. With this, you can still use your Active Directory on premises, but you can also have it in the cloud. And this way, you get to reap the benefits of both. It allows communication. And truth be told, most organizations start with a hybrid cloud model. And while some migrate to just completely public cloud model, some continue to use a hybrid cloud model. So when you think of the hybrid cloud, think flexibility. So remember how we said the public cloud was a bus and the private cloud was a car? Well, what's the hybrid cloud? Well, the hybrid cloud is the best of both worlds. It's having the ability and option to choose between a bus and a car depending on what you want to do. Remember, every organization has different needs and wants. Look at it this way. If I lived in New York City, well, I wouldn't want to own my own car. Parking there is impossible. Garages cost hundreds of dollars a month. And even if I were to drive, have you seen that traffic? No way. I'd be stuck for hours at a time. No, in this case, I would want to take public transportation. I want to take the subway and avoid all those issues. I want a public cloud. Now, what if I lived in a state that was, very spacious, like let's say Texas, right? Where sometimes owning your own car is a must because the closest store may be miles away. Well, in that instance, you could do a private cloud. Now, Josh, I use both public transportation and I use my own car depending on the situation. Now, I live in a small community where most things are within a reasonable distance. We actually have a little public bus that, for a small fee, takes you around the community based on where you're going. But sometimes I do need to drive to places. I need to do a big grocery run, maybe go to the beach or help my brother move a couch of, huge proportions, pivoted up 10 flights of stairs, right? Well, in that case, I use my car and I drive. I have a hybrid environment because I have the ability to do both. And that's why so many people are turning towards the hybrid cloud because it offers solutions to problems and provides flexibility nothing else out there. Now, as we continue our journey today, we're going to learn about different terms where one cloud model benefits more than the other. Now, for example, let's take my sister Gladys and her photos one more time. She stores them all online. Okay? All she does is connect to a network and the application does the rest. That's making use of the public cloud. Simple, quick, easy. Now, she could go the private cloud route and purchase an external hard drive, right? She could upload each picture into that hard drive and, secure that server, that hard drive on her home network and authenticate it and back them up that way. She could go through all of that. That way, she would have total control because she knows exactly where her pictures are, and the only way for someone to access them is through her physical hard drive. Now, yeah, that's a significant cost up front, right? It's a lot of work and honestly a plethora of knowledge required versus maybe a small monthly cost that would provide all of this. Now, some might prefer one. Some might prefer to have all their photos stored in the cloud and pay that monthly rate. Some might prefer the other and have it, physically stored somewhere local where they can see it. And some may even go hybrid and choose both. Maybe they want to upload their pictures and have that local device at home. Regardless of what you do, the advantages are clear. Each organization is different. They have different wants and needs. And as technology, clients, the world itself continues to evolve, so will the cloud. And there are easy ways to differentiate the three different cloud models. Remember, the public cloud requires no capital expenditure to scale up with this mode. Organizations pay for what they use. With the private cloud, while organizations have complete control over resources and security, they're also responsible for the hardware maintenance and updates. And finally, with the hybrid cloud model, remember, this provides the most flexibility, and it allows organizations to determine where they want to run their applications. Now, when it comes to the cloud models, we learned a lot. A great question comes to mind, and that is, well, Josh, how do we pay for it? That is actually why the cloud is such a fantastic solution. Because when we look at expenditure in the cloud, we can actually look at it two different ways. So first, let's actually think of a quick scenario, right? So let's say in my business, I sell pizza, okay? Well, I want to start up a website and I want to host it locally. Well, as a private cloud model, I would need to spend a lot of money up front to get myself started. I would purchase a server rack, the cables, the wires, everything I needed to get myself started. That's a lot of money up front, but over time, as long as my demand doesn't fluctuate significantly, I can expect my physical infrastructure cost to be high upfront, but I'll have a value that reduces over time. Now, if I spend $10,000 now to get set up, remember, I won't be paying that amount every month because now I own it. It's mine. But on the flip side, if my business grows and I need to scale out or up, I have to spend to do so. And that spend is permanent. I won't be able to scale back down or back in. And as we all know with technology, it is ever changing, constantly evolving, and always progressing. I mean, I got a new phone 3 months ago, and there's already a new version of the same phone coming out. Now, what I previously described is called capital expenditure or a CapEx model. CapEx is spending money upfront and creating overhead, and while again, you will not incur additional costs due to the fact that you're paying it all upfront, you're not protected from depreciation and outdated technology, right? If I buy a laptop today, next year, it might be outdated. It won't be the most recent one. If I buy a brand new car, as soon as I drive it off the lot, it's now used and has lost its value. The same goes for technology. Now the public cloud doesn't follow the CapEx model. The public cloud follows the operational expenditure model, also known as OpEx. Now OpEx is a great model because you only spend on what you use. You get billed immediately and only get charged for the products and services you need. Now, operational expenditure is the ability to spend on products and services as needed and paying as you go. And another way to demonstrate this is with the consumption-based model. Now, the consumption-based model is a model in which users only pay for the resources they use. Okay? So most providers, like Azure, have their resources set up with what's called a usage meter. And that meter tracks the consumption and based on the product, resource, or service, charges you, for only what you're using. Now, sometimes that can be measured in seconds, sometimes a monthly charge, and sometimes in other ways. But again, this allows you to only use resources as you need. Now, there are a ton of benefits when it comes to the cloud. But for the exam and today's class, let's focus on just a couple of them, beginning with high availability. Now, when it comes to moving to the cloud, there are always concerns, right? The biggest of these is the fact that cloud computing is essentially using a server. For some customers, that can be concerning. They want to know what kind of server, what does it have, right? Where is it? But most importantly, they want to know if it will have any downtime. In other words, how available is it going to be? Well, the good thing is that every reputable cloud provider is going to have high availability. This means that whatever service you are using from that cloud provider, be it the compute, the networking, or the storage, that they're going to be available. So high availability is concerned with maximizing that resource's availability. And a highly available resource is available a significantly large percentage of the time and may even approach 100% availability. But again, a small percentage of downtime is acceptable and honestly expected. Now, some services can even reach what we call 5 nines of availability, which essentially translate to about seconds. Yes, seconds of downtime in an entire month. And the official definition of high availability is as follows. A highly available resource is almost always operational and accessible to clients. Now, two great benefits that make the cloud unique are scalability and elasticity. And very simply, scalability is the ability to scale. We are adding or removing resources or adding a number of instances to our existing services. Now, when it comes to scaling, there are two ways to do it. Okay? So first, you can scale up or down, better known as scaling vertically. Or you can scale in or out, better known as scaling horizontally. And while you're like, Josh, that sounds great, what does that mean? Well, the easiest way to explain it is to think of a virtual machine. So imagine I have a virtual machine, okay, and it has a single server. My virtual machine currently has 4 gigs of RAM. But now, based on analytics that are built into Azure, it tells me, hey Josh, 4 gigs is not enough for your current needs. We need to pump it up. So what do? Well, as anyone else would do, I'm going to recreate that virtual machine, and I'm going to scale all the way up to 12 gigs of RAM. Well, guess what? Analytics comes back, and they says, hey Josh, you went a little too far. 12 gigs is far more than you actually need. We can save some money if we go down to 8 gigs, and that's the perfect number for what your environment needs. So what do? Well, once again, I'm going to recreate that virtual machine. But this time, I'm scaling down to 8 gigs. Now, important note, we're simply using RAM as a simple way to demonstrate, right? It's not isolated to RAM or even to a virtual machine. There are a number of different resources and ways that you can do this with. But as for scaling in and out, let's take that same virtual machine and it's 8 gigs. Now, sometimes it doesn't matter how strong, powerful the resource is, right? Sometimes you simply need more resources or more instances. Let's say that for the task I need to complete, a single virtual machine is not enough. I need to have multiple virtual machines running at the same time. Therefore, I'm going to scale out to not only 2, but 3 virtual machines. And then guess what? Once again, that analytics kicks in and tells me, Josh, you went overboard. You don't need 3 virtual machines. With your environment, 2 with 8 gigs is absolutely perfect. So what can I do now? Well, I can scale back in to 2 virtual machines instead of the 3. And even if I want to, scale all the way back to 1 and save myself some money. Now again, this is not just for virtual machines, but for any resource, right? Remember, sometimes you may need multiple instances, and that's when you want to scale out and add those instances. That's the beauty of the cloud, because your scalability can be endless based on the resources available to your cloud provider's data center. Now let's talk about elasticity. Now elasticity is scaling that is done automatically, okay? Very important to remember. Elasticity is scaling that is done automatically. So again, remember my booming pizza business, right? Well, let's say I have my website up and one day a famous actor, a famous athlete, or even a social media influencer sees my website and says, this is the best pizza in the world. And they post it on their social media and everyone sees it. Well, my website just, blows up, okay? I become more viral than the latest dancing trend. Well, if it were a locally hosted website, I wouldn't be able to handle all that traffic. But luckily for me, no, I hosted my website on a public cloud. Now I can scale up to increase or scale out to add instances. Now, while yes, that is much faster and better, honestly, than manually purchasing infrastructure and equipment, it's still going to take time, right? I have to manually do it. And if I waste even a second before I know it, I'm yesterday's news and I've missed my 10 minutes of fame. No. Instead, what I can do is I can create what's called an elastic response, which means that I can set up my resources to automatically add an additional resource once my current one reaches a certain threshold or metric. So for example, here I have a storage account, okay? And let's say storage account number 1 hits 80%, right? Well, typically, I would have to manually go into my portal and create another one. But with an elastic response, the system will go ahead and automatically add another storage account to deal with that traffic. And let's say it gets really bad. Well, let's say this one gets to 80%. It's going to add storage number 3. And if it gets really bad, well, keep on adding until my rule says stop. For example, I could stop at 6. I could stop at 20. It's up to me. Now, eventually, this is the best part, when traffic dies down or it gets slow and my storage accounts are back under 80%, then whatever was created beyond my original one, well, we can go ahead and automatically turn those off. This way, I only get charged for the time I used it. So again, we turned off all the ones after 3. Then we're going to turn off number 3. And heck, let's say it gets such a great point that we can turn off number 2. Then again, another social media influencer sees it, says I have the best pepperoni in the land, and then my elastic rule has to kick in because, again, my website blows up again. Automatic scaling is great because it saves me the 2 things that every business loves most: time and money. And that is the beauty of elasticity. Now, as we go back to our benefits, right? Remember, we have other ones, such as reliability. Now, reliability is the ability of a system to recover from failures and continue to function. It's also one of the pillars of the cloud. Now, the cloud, by virtue of its design, naturally supports a reliable and resilient infrastructure. It enables you to have resources deployed in different regions all around the world. So with this global scale, even if one region has a catastrophic event, well, other regions are still up and running. And you can design your applications to automatically take advantage of this increased reliability. Now, in some cases, your cloud environment itself will automatically shift to a different data center, and sometimes even to a different region. The best part about this is there's no action needed on your part. Through availability zones, region pairs, and Azure's global presence, your infrastructure is incredibly reliable in the cloud. Now, next up, we have predictability. Now, predictability in the cloud is exactly what it sounds like. The idea here is that you can always move forward with confidence. Predictability can be forced in two different ways when it comes to the cloud, right? It can be based on performance, predictability, or cost predictability. Now, with performance, there are many parameters in place to ensure that a service performs to the best of its capability, with multiple options to also improve the redundancy, such as availability zones for virtual machines, geo zones for storage accounts, and so on and so forth. Cost is also incredibly important. And later on, we'll go over many tools such as the pricing calculator and Azure Cost Management that allow you to not only get an accurate estimate, but even get projections and forecasts on what your spend will be going forward. Which brings us to security. Security is more important now than ever. And when you move to the cloud, even though you can't physically see your data, know that you are safe. In most cases, safer than you would be on premises. Think about it logically. Our data centers, we have armed guards, multiple security checkpoints. We even have weighing stations to ensure that you weigh the same way you did as you did going out. Not only do we have physical security, but we have multiple tools to help with virtual security, things like Microsoft Defender and Sentinel. We know how important it is to feel safe. And at Microsoft, we do our absolute best to make sure that while your data is in the cloud, you can always rest easy knowing it is in the best hands. Which brings us to governance. However you decide to deploy your services, cloud features support governance and compliance. Now, there are many things in place to do so, right? Things like set templates help ensure that all your deployed resources meet corporate standards and government regulatory requirements. You can update all your deployed resources to new standards as standards change. You can even use cloud-based auditing to flag any resource that's out of compliance with your current corporate standards, and it provides mitigation strategies. And let's drive that point one step further, because depending on your operating model, you can even automatically apply software patches and updates, which will help with both governance and security. Now let's get to our last benefit. Now, the last great benefit that we'll talk about is manageability. Now, in the cloud, there are two main ways to manage. One is management of the cloud, and the other is management in the cloud. So first, let's go over management of the cloud. Now, this refers to the ability to manage cloud resources in the cloud with ease. You can automatically scale resources as we showed previously. You can deploy resources with pre-configured templates, which remove any need for manual configuration. You can monitor the health of your resources and even replace any failing ones automatically. You can even receive alerts of any issues, so you're always aware in real time. That is management of the cloud. Management in the cloud. This refers to your ability to manage your cloud environment and resources through a number of different avenues. Now, throughout our course today, you'll see that we use the web portal at portal.azure.com. But as we continue through the course, you'll see that we can also manage through CLI or command line interfaces. We can use APIs and even PowerShell to manage our environment. That is manageability. So after going all these benefits, right, you can see why so many are moving to the cloud. The truth is that creating an environment, all of these benefits in an on-premises environment would be very expensive, and that would require a lot of time for most organizations. So that shows the importance of the cloud. Now at this point, we've talked about the public cloud, the private cloud, and the benefits of moving to the cloud, and the type of expenditures with OpEx and CapEx. But when you're inside of the public cloud, how do you deploy? Well, you have three options for deployment. And for your services in the cloud, it is vital you best understand the difference between the three. So that way, you can select the one that best fits your wants and your needs. So let's begin with the most basic of them, and that's Infrastructure as a Service, or IaaS. Now, as you continue your journey with the cloud and get more comfortable, you're going to be on a first name basis with these terms, okay? You no longer call them by their full name. But the key thing I want you to notice is from this word, okay, from this phrase, infrastructure. This is the service we're looking for from our cloud provider, the physical infrastructure. When we look at the cloud, we're still renting those capabilities. With infrastructure as a service, we're just asking that cloud provider to have access to the data centers, the physical servers, the physical networks, the physical storage. And in turn, they are taking care of the physical aspects or the physical infrastructure. It's the most basic cloud computing services category in the public cloud. And because of that, when a lot of companies begin their migration to the public cloud, they actually start off by choosing IaaS services because it's the closest thing to on-premises, right? It's the closest thing to a data center or a private cloud. Now, the only big difference is that, again, because it's a public cloud model, they're not in charge of the infrastructure. They don't have to rack and stack. Now, what they are in charge of, though, is the operating system, patching the operating system, and installing their applications. But again, what they're not responsible for is the physical infrastructure. Now, a popular term that many will do is called lift and shift, which is where they will literally take their on-premises data, lift it, and shift it over to the cloud. That honestly makes it simple for migration. IaaS is typically the best deployment model for migration because with IaaS, you offload the hassle and responsibilities of the maintenance, ownership of a data center, and the physical infrastructure that comes with it to the cloud provider. Now, the next level for deployment is Platform as a Service, or PaaS. Here, we keep the same level as Infrastructure as a Service, or IaaS, remember, physical components of compute, network, and storage. However, this time, we don't just give up some infrastructure. We give up all infrastructure. We are not responsible for the physical or the virtual infrastructure. And this works. It truly works because PaaS is designed to provide a service where you can harness your focus. PaaS is for the creation, development, and launch deployment of applications or solutions. So in turn, you worry about your application. You don't worry about what that server physically is. You don't worry about creating an operating system that supports it. No. Your application is your focus. Your focus is to simply build out that application. And it's ideal and perfect for testing, building, and deploying that application while giving up, again, the physical and virtual infrastructure. Now, the third and final mode of deployment is SaaS, or Software as a Service. Now, Software as a Service is where a cloud provider is giving you access to some sort of application, such as OneDrive or Dynamics 365. Now, SaaS is primarily for multi-tenant consumption of cloud solutions, because here, you as a consumer are simply using the application. You're not writing lines and lines of code. You're not testing and developing the operating system and making sure it's functional and compatible. You're not even concerned with what server it runs on. No. You're simply purchasing, in most cases, an annual or monthly subscription. You're paying to use this piece of software or application, and the cloud provider is taking care of everything else. You're not doing the patches, you're not doing the updates, and you may get an update, but you don't have to do anything but click install. So I remember my nephew and my sister, they were thinking of software as a service. So to summarize, SaaS is a finished solution that has been deployed and consumed. Now looking at IaaS, PaaS, and SaaS, remember, you are not limited to using just one. As you deploy and work in the cloud, you can pick and choose the one that works best for you. With infrastructure as a service, this gives you that flexibility because all the cloud providers taking care of is the physical components. And remember, most similar to an on-premises environment. With platform as a service, it's all about the apps. If you're a developer and you don't want to concern yourself with the server, you don't. Hand it off to your cloud provider with PaaS. And with SaaS, think of Microsoft 365. It's software, and the cloud provider takes care of everything else. It's so important that you understand that regardless of which deployment model you choose, the responsibility is going to change based off of your selection. So let's take a quick look at the diagram. Look at the column all the way on your far right. That's the on-premises model. Remember, in this model, you are in charge of everything.
Remember, total control, right?
You're responsible for buying the hardware, for maintaining it, for updating it. But as we move into IaaS, PaaS, and SaaS, we now move into what's called a shared responsibility model. We're no longer in charge of it all. No. Now we share our responsibility with our cloud provider. And depending on our wants and needs,
We can choose how much to share.
remember, with IaaS, the cloud provider is only taking charge of the physical infrastructure. With PaaS, this is for the developers. You're worried about your application. You're not worried about infrastructure because all that responsibility, that's on the cloud provider. What you are in charge of is your security, your apps, and what data and access you have. Now with SaaS, while you're giving over basically everything to the cloud provider, you still have control over the data that you load and the users you give access to. What I want you to remember is that no matter where you go, you will always maintain responsibility over your information, data, devices, account, and identities. And being able to choose between different deployment models gives you that flexibility to do whatever works best for you. The goal here at Microsoft is to provide anyone and everyone with the ability to accomplish whatever they want, whatever they need, and empower them to achieve more.
Now that wraps up Module 1. So let's talk about what we've gone over. We began with cloud computing and the 3 cloud types, right? We talked about the public cloud, the private cloud, and the hybrid cloud. We also spoke how we pay for them using either CapEx or OpEx with that consumption-based model. And of course, don't forget those 8-grade cloud benefits, from scalability to security and many others. And to wrap up the wrap-up, our 3 deployment types, right? We went through infrastructure as a service, known as IaaS, platform as a service, known as PaaS, and software as a service, known as SaaS. We also went through how responsibilities change based on how we deploy. Remember, this was foundational. For some of you, this may have been brand new. For others, it was a very nice refresher. Whatever the case, thank you so much so far. And now that we've gone over our cloud models, I feel that we've all earned a wonderful break. When we come back from the break, we'll start off with our next lesson. We had a great time going over cloud concepts in the previous lesson, but now we're going to go to some of the larger lessons of the entire course. Now, this lesson can be split up into a couple of separate mini lessons, but it's important to understand that the focus here is we're going to talk about Azure's architecture and services. So the first part, we're going to talk about Azure's architectural components, and then from there, we're going to talk about the compute. Now, that entire section is full of a lot of great topics. But again, for this lesson, we're going to be going over the architectural components as well as various compute and other services that are available. In other lessons going forward, we're going to talk about the networking services, storage, and identity access and security. But before we do, let's start off with that first lesson. Let's talk about the architectural components of Azure. In this lesson, we're going to go over the Azure architecture and the various ways that Azure creates redundancies across the globe. We'll also create an Azure resource in our portal, but first, let's begin by understanding how Azure groups and its data centers are collected, and that's in regions. Now again, the cloud isn't actually up there floating in the sky. Now, in fact, the cloud is simply your cloud provider's data centers that are spread out all across the globe. And Azure has what's called a global reach that allows you to place your resources closer to your customers and to your users. And the way that Microsoft Azure breaks down our data centers is we group them into what's called regions. Regions are groupings of one or more data centers, and these regions are all across the world. They're constantly updating, so much so that in fact, this map on this slide may already be outdated. Last I checked, we have over 60 regions spread out across 140 different countries. That was a really cool way to explore and see all the different satellites by navigating to our webpage. There you'll be able to see the over 60 different countries that are represented inside of our Azure infrastructure. And again, each of these countries have multiple regions within them. For example, we'll have the United States, Canada, Mexico in one region, and then you'll have Brazil in another one, and then you can have Switzerland and such and others. We even have Azure Government and Azure China, which are physically isolated instances of Azure. And as you explore the globe, you'll be able to see the locations there. But an important thing to always remember is that as you deploy your resources inside of Azure, you always need to select the region. And dependent on the region that you select, it can impact several different things. Now, the first thing it can impact is what services are available in that region. Not all services have the exact same services available. Now, again, a lot of regions are going to be similar, but they won't be identical. So that's something you want to be aware of. Number two, it's going to impact the cost. Now, the cost may increase or decrease depending on the region you select, because the cost of doing business in one region compared to another may vary. And I can tell you right now with confidence, right? The cost of doing business in Iowa compared to the cost of doing business in Switzerland are going to be different. So again, that's going to impact your cost. And then finally, when we're choosing our region, we also want to be aware of data residency requirements and other compliance offerings. Now, this is particularly important when it comes to government entities as well as certain industries like finance, where they may have very strict data regulations that you need to hold to. So again, different regions are going to have different data residency and different compliance offerings. But what's cool about regions? Well, everything. But remember, when we talk about the cloud, we talk about agility, right? We want speed. Well, guess what? Right now, I'm sitting here. If I wanted to, I can deploy a virtual machine at a database in Africa, at a database on the west coast of the United States, at a database in Canada. And I can do all of that in just a matter of seconds. And that's the benefit of the cloud. Because prior to the cloud, when we were in that on-premises format, the process would be much more difficult and far more time consuming, right? I'd have to get on a plane. I'd have to fly there. I'd have to purchase all the equipment. I'd have to plug everything up. I'd have to set it all up. I'd have to, provision it. I don't have to do any of that. Not when I'm using the cloud. And that's the beauty of regions. Because with regions, we can be anywhere at any time. Remember, regions are one or more data centers spread all across the globe. And every time that you deploy a service or a resource, you must select a region to deploy it. Now, another great option to improve redundancy is called an availability zone. Now, availability zones are physically separate locations within each Azure region that are tolerant to local failures. Again, local failures. Essentially, what you're doing is you're deploying multiple instances of that virtual machine across multiple data centers, again, in the same region. And that's the key point here. So let's say, for example, I deploy in the East US region, okay? I'll have 3 different data centers. So I'll have, data center 1, data center 2, and data center 3. And in each data center, I have a copy of my virtual machine spread across each of those data centers. This way, even if one data center goes down, well, my services are going to be up and running in the other 2. Now, it's important to note, there is no cost to use an availability zone. All you're paying for is the virtual machine itself. So, if you create 3 identical copies of the virtual machine and you place them into separate data centers within the same region, there's no cost to put them in those separate data centers. The only cost you're incurring is the cost of those virtual machines. So essentially, you can design resilient solutions by using Azure services that use availability zones. Again, remember, availability zones are physical separation by data center in the same region. This is used to prevent any type of downtime, okay? So any type of data center outage. And I know exactly what you're thinking. Okay, Josh, if availability zones help protect my services from a data center outage, well, what if the entire region goes down? Well, my fine friends, I would then introduce you to my other fine friend, region pairs. Now that you know that Microsoft has regions spread out all across the globe, you can begin to understand the importance of being able to recover from disasters. And disaster recovery is a really important piece of any cloud provider's plan. With Microsoft and Azure, what we've done is we've created something ingenious called region pairs. In every single region that you deploy a service, something wonderful happens. And that wonderful thing is that your services are automatically going to be replicated. Now, some small fine print here. On the site, it's going to say some services. By that, it simply means things like monitoring tools that wouldn't necessarily make sense to be replicated, those won't be replicated. But again, those are the anomaly. Your virtual machines, your databases, your core business use services and resources, those are going to be automatically replicated in a region that is at least 300 miles away. And this way, it meets the ISO standards for disaster recovery. So, in the event that there is a region-wide outage, and by region-wide, I mean every single data center in that region is gone or is out, what's the solution? Well, the solution is that your resources will fail over to that secondary region. Let me point out a couple of things about region pairs. First, There are no charges for the region pairs, okay? This is done automatically to help ensure that Microsoft keeps your services up and running, right? We do this to maintain that high availability and meet your requirements. Number two, it's done automatically. You don't have to make any changes, but you don't have access to that data. That data is not something used for your disaster recovery plan. So it's encouraged that you still have your own business disaster recovery plan because this is Microsoft's disaster recovery plan. And then third, these regions are replicating your data. So if we do any type of major updates to the regions, we're going to make sure those updates and changes aren't deployed until your region pair is ready. Because in an outage, recovery of one region out of every pair is going to be prioritized. So remember that Azure system updates are rolled out sequentially. So what I want you to understand most when it comes to region pairs is this is automatically done by Azure as part of their disaster recovery plan. And whatever region you select, your services are going to be automatically replicated in the secondary region pair. Now, I know I alluded to this before, but another area I want to touch on is about the different Azure regions that exist outside of the norm. So we have two physically isolated instances of Azure. Now, the first one we'll talk about is Azure US Government Services. Now, this very specifically is going to meet the compliance needs of the US government. Now, notice I said the US government because this is not all government and government entities. This is very specific to the US government. Think of the Department of Defense, right? They're using Azure government regions. Now, they're going to have additional compliance requirements that we don't need outside of the US government. For example, let's say FedRAMP, right? You would use an Azure government subscription. You can't use a public one because FedRAMP is only available in the US government services. Now, as Josh, I can't just say, wow, that sounds cool. And I go to my portal, and inside of my portal, I want to deploy inside of the US government region. No way. Not going to happen. I need to be authorized. So remember, you need to be authenticated and authorized to deploy in US government because this is for state and local governments. Now, the other one, this is really important when it comes to data residency because China has a very, very strict requirement and it has strict rules when it comes to how their data is stored. And truth is, due to those strict requirements, it was difficult for foreign public cloud services to meet those and be allowed in China. You want to take a guess who the first one was? That's right, Azure. Azure was the first foreign public cloud services to meet all of China's requirements. How did we do it? Well, we got creative, okay? Because the way that we actually have Azure inside of China is Azure is there, but it's operated by a Chinese company called 21 Vianet. And 21 Vianet is managing and meeting all of those requirements. So their data all stays in China and it meets the compliance. Again, this is a physically isolated instance of Azure. So it's not part of your regular Azure regions, right? This is, again, a separate one. So if you're deploying in China, you're actually deploying through 21 Vianet. So those are your two other instances of Azure. Azure Government and Azure China. So very quickly here, we're going to show you a demo of Azure's global infrastructure. When I say that we are everywhere, I mean we are everywhere. The best part about this is you can navigate to this anytime you want. Remember how I said we're constantly updating? Well, if you go to infrastructuremap.microsoft.com, you're able to see the map. So right here on the right side, you'll see that we get news updates. So even it'll tell us what's going on in the world of Azure. Now, as we explore the map, we can actually go wherever we want. So actually, let's take a look at a data center in the United States. So let's look at this one in central US. Now, as you can see, it's not only going to tell us what data center it is, but it's going to show us that it has regions with availability zones. It's going to tell us the location, which is Iowa. Now note, it's not giving us an exact location. Now that's for security purposes. Again, you know you're in Iowa, but not exactly where in Iowa. Now it's also letting you know where the data residency is, because it's stored at rest in the United States. It's telling us what year it opened. It's also letting us know the products and services that it offers. It's letting us know our sustainability. It's giving us all this information about this exact data center. Now, how about we take a look at a data center on the other side? Let's take a look at the data center all the way over here in South Africa North. Now look at this. This data center also has availability zones. Its location is Johannesburg, and it's stored at rest in South Africa. Now this one opened in 2019. And look at all the products and the disaster recovery it has. As you can see, we have data centers all over the world. But one of my favorite things is we also have points of presence all over the world. My favorite point of presence has to be this one all by itself right out here. And that's in New Zealand. Now this is a point of presence, and as you can see, it's actually going to be a region that is coming soon. So that's the best part about Azure. Not only do we have points of presence all around the globe, but sometimes we can even make those data centers. So it's such a great thing to look at and see that when we say we have globability, we mean it. Okay, now that we're back from the demo and we understand the physical architectural components that make up the cloud, let's take a look at the logical architectural components. Remember in the earlier lesson, when we introduced the public cloud, right? We said essentially, that's a place where you're renting resources from a cloud provider. Well, in this case, and in the case of Azure, you as customers can rent compute, you can rent networking, you can rent storage, and analytics capabilities from Azure to build out your workflows and applications. And by definition, an Azure resource is a manageable item that is available through Azure. They're essentially services that users use in Azure, and examples of resources that we will see throughout this course today are virtual machines, storage accounts, virtual networks, app services, SQL database, and functions. Now you're going to hear us say things like deploying a resource or creating a service, and just know that resource and service are used interchangeably in these contexts. Now in Azure, we can deploy these resources when we need them and delete them when we no longer need them. Now take a second and absorb that sentence. By using Microsoft Azure instead of an on-premises data center, with simply the clicks of a few buttons, we can deploy virtual machines, storage accounts, app services, virtual networks to build out our workloads. And then again, with the clicks of just a couple more buttons, we can delete those resources in Microsoft Azure when we no longer need them. That way, we pay only for what we use. I mean, mind-blowing. So services and solutions within Azure is what we mean when we refer to resources. And throughout today, we'll be introducing you to these resources, so that way we can all get a very high-level understanding of each of them. Now, within Azure, the resources are required to be grouped into, say, logical folders, and those are called resource groups. Now, resource groups, okay, those are fantastic because when it comes to building a resource or deploying a resource, you always have to select a region for your resource, but you also have to put them into what's called a resource group. And the way I like to think about resource groups is like a container. Now, unfortunately, container is the official term for it, but it gets used often in Azure. So I want you to kind of think of it like an organizational bucket, okay? And the reason, we don't want you to think container and use that because, again, it's used so often we don't want you to get confused. So think of it as like an organizational bucket, okay? And in this bucket, that's where we're putting all of our resources, okay? We're putting a virtual machine, we're putting a storage shelf, we're putting all of that. The best part about it is that it's up to you how you want to group them. Now, every resource you create has to exist in a resource group. And more importantly, it can only exist in one resource group at a time. But again, you can mix and match, right? You can have resources in different regions, different types supporting different applications, all within the same resource group. Bottom line, doesn't matter how you organize your resources. Now, there are some best practices around it. For example, at Microsoft, we recommend that you either do it based off of, application, security principles, or life cycle. Now, a great example to show about how you can do what you want with your resource groups is my wife and I, okay? My wife and I have identical dressers for our clothes, but we organize them in different ways. You see, I have a philosophy. I like to have all my shirts in one drawer, all my pants in another drawer, and so on and so forth. My wife, however, doesn't like that. My wife organizes her drawers by outfits. So she'll have a couple of outfits per drawer. This way, all she has to do is take out the entire outfit. To each their own. Because when grouping, you can do what you want. You can do what works best for you or whatever your organization decides. However, there are a couple of very important things to know about resource groups. Number one, once I delete that resource group, it deletes all the resources inside. Again, for those who didn't hear me, it deletes all the resources inside. Why? Because they have a parent-child inheritance relationship between the resources and the groups they're in. So if I do something to the group, it's going to affect every resource within it. Number two, resources can be moved to different resource groups. So for example, I can move a virtual machine from resource group A, and I can move it to resource group B. Number three, resource groups cannot be nested. Number four, applications can utilize multiple resource groups. And number five, I know we said this before, but again, a resource can only exist in one resource group. Again, it doesn't matter how you organize your resources, okay? That's an architectural choice. And likely, your organization has a structure that they like, that's the way they want to do things. But if you're new to migration, I would strongly recommend checking out our cloud adoption framework. There's some great practices around there and, even naming conventions. Now, before we get into the portal, right, let's talk about Azure subscriptions. Now, an Azure subscription is an agreement with Microsoft to use one or more Microsoft Cloud platforms or services. It's not going to be an account, okay? Because an account can have multiple subscriptions. In fact, even if you've never logged into Azure today, you could go to portal.azure.com, you could log in with your Microsoft account, and then ta-da, poof, abracadabra, you have an Azure account. But you really can't do anything because in order to actually do something, you need a subscription. Because just like how resource groups are logical folders of resources, well, we like to say that Azure subscriptions are logical spaces containing resource groups and are used as a billing and access control boundary. And when we say access control boundary, we're answering the question of who do we want to have access to this subscription, which means that by inheritance, who do we want to have access to the resource groups that are within that subscription? What about the resources that are within the resource groups that are within the subscription, right? Now, we're going to talk about something later called role-based access control, and we're going to get a lot more insight, and that's how we can control it. But again, when we say a billing boundary, what we mean is that you're going to get billed for each subscription separately. And again, think of a subscription as an organizational unit for your resource groups because every Azure subscription gets its own invoice. So this way you can control who and what has access to it. Now, a little bit during our demonstration, we're going to log into our Azure portal. you're going to be able to see our subscription. But just know that each and every subscription gets its own billing and invoice report. You control who and what has access to that subscription, and ultimately the resources within it. And if we zoom out one more time and look at the bigger picture, then we have management groups. So I kind of want you to think of management groups as the top of the pyramid of the org chart of Azure, right? Management groups provide a scope above subscriptions because they allow you to group multiple subscriptions. And that's incredibly useful, okay? Especially when you have a lot of different subscriptions. So for example, let's say you have your element, test, and product subscriptions, okay? Well, maybe you want to apply some type of policy, or think of it like a governance tool, right? You want to make a way that no one named Josh Rodriguez can create a $30,000 virtual machine. Again, well, instead of having to go in and apply that policy into each single subscription, well, what we can do is we can create a management group, right? And put those subscriptions within it, because that's going to lock down the total cost of virtual machines that they can deploy. That's going to then be inherited by each subscription, which is then going to be inherited by every single resource group, and then inherited by every single resource. So again, this is a management tool to apply more governance to multiple subscriptions and give you that control. Now, especially if you're in a large enterprise organization, you may have hundreds of different subscriptions. Can you imagine that administrative nightmare to have to go through and try to manage each one individually? No thanks, okay? So when you think of the highest level of grouping, think management groups. There's a few things to note when it comes to management groups, okay? Number one, management groups are groupings that help you manage, access, policy, and compliance for multiple subscriptions. Number two, management groups can include multiple Azure subscriptions. Number three, subscriptions inherit conditions applied to that management group. Four is 10,000 management groups can be supported in a single directory. 10,000. Number five, a management group tree can support up to 6 levels of depth. And it's important to note that this limit doesn't include the root level or the subscription level. So now, without further ado, let's go into the portal and let's create some resources. In this demonstration, we're going to create a couple of resources. But what we're going to do is we're actually going to create a resource group and a virtual machine at the same time. So as you can see here, this is our Azure portal. Okay, this is our first step into the portal. But don't worry, we're going to go slow. We're going to take our time. We're going to have some fun. So this being the portal, which is basically portal.azure.com. And as you can see here, right at the front, you're going to see our Azure services. Now, no matter the type of account, again, this is how it's going to look. Okay. Now here, you're going to see these services. So you're going to see it says create a resource. You're going to see your most recent services. And then at the end, it's going to show you more services. So while these may change, this is always going to remain the same. But let's go ahead and start by creating a resource. So when I click create a resource, you're going to see the popular Azure services. And of course, virtual machine is number one. But what's virtual machine? Well, it's actually compute. So I can click compute, and you can see that when it comes to compute services, virtual machine is right here. Now, another way I could do it is I can actually simply click the top, click virtual machines, and go straight from here. So let's click virtual machines. And as you can see, we can go ahead and create one. So I'm going to click virtual machine, so we can go ahead and begin creating our virtual machine. Now again, a couple of things I want you to note as we create our virtual machine, or as we create our first resource. We always have to look for those red asterisks, because those are letting us know things that we have to select. And as we've said before, The first thing you have to have is a subscription, because all resources in an Azure subscription are built together. So we already have our subscription ready to go. But once we have our subscription, we also need a resource group. Now, a resource group is a collection of resources that share that same lifecycle, permissions, and policies. So we're going to go ahead and hit Create New. Now we can name our resource group, and we want to make it unique so that way we're not confusing with anything. But again, for the sake of this course, we're going to call it resource group, and then we're just going to type in a couple of random numbers. So I'm going to go ahead, OK, and now we have our resource group. Our next step is to name our virtual machine. Now remember, virtual machine is so important because we want to make sure we're naming it properly. But again, for the sake of this course, we're going to call it virtual machine and then put in a couple of random numbers. Now the region that we want to put it in matters, because again, if we put it in a different region, it might cost more. Or you want to put it closer to our customers, or closer to ourselves, or somewhere in between. So you have tons of regions that you can choose from. So you have anything from US East to Australia East to Korea Central, and we'll go over regions a lot more. Now I'm going to keep it in US East for now. Okay? So you're going to see that you have availability options as well. As we scroll down, we have tons of options on what we want to do with our availability. Do we want to put it in an availability zone? Do we want to put it in a virtual machine scale set? Do we want to put it in an availability set? It's entirely up to us what we want to do. But again, for the sake of the demonstration, let's leave it in an availability zone. Now we can also choose how many zones we want to put it in. And if we were to put it in 2 or 3, then the system immediately is letting us know that based on the number of availability zones selected, which is 3 virtual machines will be created. No, I don't want to pay for all that right now, so we're just going to leave it in a single zone. Now you also have your security type and your image. So with your image, you can configure it however you want to, because from there you also select your size. So the size of the virtual machine determines, how strong or how powerful that resource is. But it's also going to affect your cost. So for now, we're going to leave it at that standard size. That's going to cost us about $53.29 a month. Now, when it comes to the administrator account, this is very important, okay? Because we can have an SSH public key. But I want to do username and password. So we're going to call it Azure user as our username, okay? As you can see, naming conventions were good. And then we want to put a password. So we'll put a password, and I'm not sharing that just in case you try to connect to it, okay? So here we go. Perfect. And there's our password. Now, we can allow different selected ports as well if we wanted to. So we can allow the HTTP or the HTTPS. But for now, we're going to leave it the way it is. Let's look at the top and let's look at disks. So our next section to look at is disks. And here, we determine what type of disk type we want. So we can choose from 3. We can have a premium solid-state drive, a standard solid-state drive, or a standard hard drive disk. I want this virtual machine to be fast, so I'm going to stay with the premium solid-state drive. Another option to remember, and for maintenance purposes, is you can delete this drive when you delete the virtual machine. Now, sometimes you may not want to do that, so you can go ahead and uncheck this. This way, if you delete the virtual machine, the disk will stay. But I'm going to go ahead and select it and make sure that if my virtual machine gets deleted, I also want to delete the disk with it. Now from there, you can check your encryption type, but what we're actually going to go to is we're going to go to our networking tab. Now our networking tab, this is something I want you to pay attention to. When you create certain resources, other resources are created with it. So look here, a VNet is being created along with our virtual machine. Now we can decide what we want to do. We can put public inbound ports. We can select what inbound ports are there. So let's go ahead and add RDP. which is Remote Desktop Protocol, and see, maybe later we'll connect to it. So we scroll down and we can take a look at load balancing options, but again, for now, we're going to leave it like that. We can look at our management tabs, which allow us to manage it a little bit further. We can look at our monitoring options for our virtual machine. We can even look at advanced options. Now, the last thing is your tags. Now, for your tags, again, this is just name value pairs to make it a little bit easier to identify, but we won't worry about that. We're going to go ahead and click Review and Create, and hopefully it passes our validation. So our resource manager's checking that in the background, and look at that, validation passed. And it's going to give us an estimate on essentially what our costs are going to be, where it's going, all that great information. But we're going to go ahead, scroll down, and we are going to select Create. Now, as soon as I hit Create, the portal is at work. It's doing everything it can to initialize that deployment, have that virtual machine ready to go as soon as possible. And again, sometimes it can take a matter of seconds for it to deploy and be ready to go. Now, if we were just creating a virtual machine, the process obviously would be a lot quicker. But what are we doing? We're creating that resource group. We're creating that virtual machine. We're creating that VNet. We also put that RDP access on it. So that's a lot of configuration. That's a lot of things going on at the same time. But remember, if we were on premises, well, this would take a lot longer. We would have to rack and stack. We would have to update. We would have to buy. There's so many things that we would have to do in order for for us to have the same type of infrastructure. Whereas here, as you saw, we went through it very slowly, and yet, look at that. Right on time, just as I said it. Our deployment is complete, and our virtual machine is ready to go. So let's take a look. Let's go back to our home and look at the virtual machine with so many numbers. And it is ready to go, and it's actually running right now. And that is how easy it is to create a resource in Azure. All right, so now that we created our virtual machine and our resource group, let's go over some compute and networking. Okay, so we know the setup of Azure, right? We understand the architectural components. We understand how the portal works now. And remember, that's what we're going to be using today, the portal. But I want to discuss some of the core Azure workload products. These workload products are services or resources. Now remember, if we think back to our earlier lesson, right? What are we renting from our cloud provider? Well, we're renting compute, networking, and storage. Let's focus on that very first one, compute. Now remember, that's the brain, right? That's the engine behind everything that's hoping to run all of our applications. Now in Azure, there are over 25 different compute offerings. Don't worry, we won't be talking about all of them. No, today, we're only going to be talking about 5. Remember, this is a fundamentals class. I'm not going to be able to talk about everything, but we're going to talk about a lot. However, if you want to learn more about some of the different compute offerings, especially in more detail, I strongly recommend that you check out AZ 104. That's our administrator course. But essentially, when we're looking at our compute services inside of Azure, this is where we're renting specifically the disk, the processors, the memory, the operating systems, all from Azure. Now, depending on which type of cloud deployment option you decide to pick, whether it be IaaS, PaaS, or SaaS, your responsibility level when it comes to managing those tools is going to vary. So let's take a look at these 5, okay? We have virtual machines, app services, container instances, Azure Kubernetes services, and Azure Virtual Desktop. And let's start with virtual machines. And with virtual machines, we've discussed this a little about in the past. We talked about it with availability zones. But simply put, our virtual machine is just an emulation of a physical server like you would have in your on-premises environment. This is an IaaS offering. So remember that IaaS is an offering of the lowest level of cloud computing. where all you're taking from the cloud provider is the physical compute. So the physical data center, the physical networking, and the physical storage. Otherwise, everything else pretty much remains the same as it would be on premises. Now, what we found is that with most organizations, their first dip in the water, their first step into the cloud is usually IaaS. And they usually start off with virtual machines because they're a type of product that they're very similar with, right? It gives them a feeling of comfort. You're still able to select your operating system. You're still installing that operating system. You're patching updates. You're customizing it. The difference is you're not doing that physical racking and stacking. So this is going to be one of your infrastructure as a service offerings where you're managing everything except those physical components. Now, if you recall from earlier, right, the next level up from infrastructure is PaaS or platform as a service. Well, in Microsoft data centers, there are physical servers that host these virtual machines. Now, if any of you have used VMware before, Microsoft uses a similar hypervisor. We call it Hyper-V. Now, Hyper-V is the emulation software that is used to abstract the compute, networking, and storage from the physical host in the Microsoft data center. This way, you as an Azure customer have the flexibility of virtualization by using an Azure virtual machine without having to be responsible for purchasing, maintaining, and updating the physical hardware components necessary for the VM to run. Now, with regards to virtual machines, there are many availability options for Azure virtual machines. This means that you can decide if you want just one virtual machine, just for testing, developmental, or even minor tasks. Or maybe you want to make your Azure virtual machines even more highly available. Maybe you want to make them redundant. Maybe you want to add a resiliency to it. Maybe you want to make them more reliable. And while, there are a couple of options available, let's start off with one of our first ones, and that's with virtual machine scale sets. Virtual machine scale sets let you create and manage a group of load-balanced virtual machines. The number of virtual machines can automatically increase or decrease in response to demand or a defined schedule. Scale sets provide high availability to your applications, and they honestly allow you to centrally manage, configure, and update a large number of virtual machines. And with virtual machine scale sets, you can build large-scale services for areas, things like compute, big data, and container workloads. This is what we're talking about when we're talking about elasticity. Now, why would you want to use virtual machine scale sets? Well, in order to provide redundancy and improve performance, sometimes applications are typically distributed across multiple instances. So you may access your application through a load balancer that distributes requests to one of the application instances. And if you need to perform maintenance or you need to update an application instance, then your customers are then distributed to another available application instance. And to keep up with extra customer demand, sometimes you may need to increase the number of application instances that run your application. And Azure Virtual Machine Scale Sets provide that management capability. They provide it for your applications that run across and even tons of virtual machines, right? Automatic scaling of resources and load balancing of traffic. Some of the best benefits are pretty clear, right? Number one, they're easy to create and it's easy to manage multiple virtual machines. Number two, they also provide high availability and application resiliency. Number three, they allow your application to automatically scale as your resource demands change. Number four, they work at large scale, with some sets supporting up to 1,000 virtual machine instances. That's not the only way you can do it. We also have what's called virtual machine availability sets. This is another availability option when using Azure virtual machines. So, what is an availability set? Well, before the existence of availability zones, which we talked about earlier, remember, groupings of data centers in a single region with independent power, cooling, and networking, customers wanted an availability option inside of a data center. right? Well, an availability set is a logical grouping of virtual machines that are spread across fault domains in one data center to provide redundancy. And that's key, in one data center, right? Well, how do they work? Each virtual machine in your availability set is assigned an update domain and a fault domain by the underlying Azure platform. Each availability set can be configured with up to 3 fault domains and 20 update domains. Now, fault domain group virtual machines are based on common power and networking. So think of it as a physical grouping of these virtual machines. So each rack of servers with its own power supply and network switch is one fault domain. There are 3 racks of servers as we have on this slide. It means that we have 3 fault domains. A fault domain is there so that if part of the data center fails, then other servers will not be taken down with it. And an update domain is a logical group of underlying hardware that can undergo maintenance or be rebooted at the same time. Update domains make sure that your systems can be updated without any interruption and without the main services going offline. Update domains they're only ever updated one at a time, right? 2 would never be updated at the same time because this is how service outages are avoided. Now let's go into the portal one more time and do another demonstration. All right, in this demonstration, what we're going to do is we're going to access one of our virtual machines and connect to it through RDP, Remote Desktop Protocol. So let's go ahead and do that. So I'm gonna actually click right here, this virtual machine that I already have ready to go. And as you can see, it's currently running. So I'm gonna hit connect and go to the RDP button. Now, as I've done this before, you're gonna see a number next to it, but again, don't worry about that when you're downloading it. So I'm gonna go ahead and click download RDP file. And I'm gonna click right here, open file. Now, when I click open file, I'm gonna hit connect. Now, once I hit connect, it's gonna ask me for those credentials. Now remember, when we created that virtual machine, we put it as Azure user. So now all we have to do is put in our password and make sure, obviously, it's the same password that we had previously. Now, once we do, we can go ahead and click OK. And once we hit OK, we're gonna get some certifications and things like that. Just go ahead and hit yes and make sure it patches through. And look at that. Look at how quick it was to open our local server. So I can go ahead and close all of this out if I want to, but essentially this is letting me know this is my server manager dashboard. But I'm gonna minimize it for now. And as you can see, look at that. This is our virtual machine. This is what we're using. How easy was it for us to access this through our remote desktop protocol? It's a click of a couple of buttons. And look at the speed in which we did it. That shows how easy it is to use Azure. All right, great. Now that we got that demo done, let me introduce you to Azure Virtual Desktop. Sometimes, due to technological advancements and other factors, the world has to adapt and create new services. Azure Virtual Desktop is one of those services because Azure Virtual Desktop enables you to create virtual machines that one or even multiple users can use at the same time. And you can virtualize your own applications as well as things like Microsoft 365 and Windows applications that users can access from their own device. Azure Virtual Desktop is a service that allows you to run a virtual Windows desktop. And it's great because with it, you can easily scale a remote workforce. And it essentially allows you to host almost an unlimited number of desktops for your users by having a pool of resources that support it. Now, Azure Virtual Desktop is a desktop and application virtualization service that runs on the cloud. It enables your users to use a cloud-hosted version of Windows from any location. And Azure Virtual Desktop works across devices like Windows, Mac, iOS, Android, Linux, and yeah, it even has HTML5 app support. It works with apps that you can use to access remote desktops and apps. You can even use almost every modern browser to access Azure Virtual Desktop hosted experience. Now, why would we use Azure Virtual Desktop? Well, one of the most common ways that we see Azure Virtual Desktop being used is from a bring your own device perspective. It's essentially, like we said, it allows you to log into a virtual desktop,
but you're still using your own device. So there's a separation of security between the two.
and some of you may have used Azure Virtual Desktop yourself. Some of you may have heard of others in your organization using this service, especially, how we've had transitions where some jobs are from home and some are virtual. Well, in my team, I'm part of a global team. And sometimes you get new hires, and due to whatever reason, right, sometimes their Microsoft device isn't ready. So while a new hire waits on their Microsoft device to get shipped to them, what would they use instead? Well, they use Azure Virtual Desktop on their own personal device in the meantime. This way, they're still able to connect without missing a beat. Another platform as a service offering is Azure Container Services. Now, if you aren't familiar with them, containers are lightweight and they're designed to be created, scaled out, agile, and stopped dynamically. Now, with a virtual machine, you as a customer are still responsible for the patching of the operating system and responsible for the virtual infrastructure. Remember, virtual machines are IaaS offerings. And the truth is the operating system takes up quite a bit of space. And what if instead of having an operating system that takes up quite a bit of space for that virtual machine, what if instead you wanted a lightweight environment for running your applications? Well, containers may be that solution. Because typically when you have a virtual machine, you have that operating system. And like we said, that operating system can take up gigs and gigs of space. But with containers, you only abstract what is needed to run the application. And in Azure, there are two types of container services. Now, first up is Azure Container Instances, also known as ACI. Now, if you're only deploying one, maybe two containers, this is what you're using, okay? Because these are more for lift and shift occasions, okay? You wouldn't use this for an enterprise-wide deployment, okay? This is, again, it's like for single use. So it's for a single container and a single application here and there. But if you are running any more than two containers, really two or more, then you should leverage something called Azure Kubernetes Service, also known as AKS. Think of this like an orchestration system with a lot more management oversight. Orchestration is the task of automating, managing, and interacting with a large number of containers. So essentially, you can create pods of all your different container images, and this way you can very, very quickly scale up. Now, a good example of a container is to imagine your website backend has reached capacity, okay? But the front end and storage aren't being stressed. Well, with containers, you could scale specifically the back end separately to improve performance. Now, if something necessitated such a change, you could also choose to change the storage service or modify the front end. And you could do all of this without impacting any of the other components. And that brings us to Azure Functions and serverless computing. Now, serverless computing is the evolution of cloud platforms in the direction of pure cloud native code. The serverless brings developers closer to business logic while insulating them from infrastructure concerns, right? It's a pattern that doesn't imply no server, okay, but rather less server. Serverless computing services are cloud-based execution environments, and serverless code is event-driven. Azure Functions is a serverless coding platform that allows us to build event-based applications. So it supports most of the popular languages and frameworks like .NET, Java, Python, PowerShell, and all the other ones. Again, you don't need to know what all these languages are, but just know that Azure Functions supports it. With Azure Functions, think of blocks of code written by your developers to solve a problem. And this code gets triggered by an event. Now, the code may be triggered by anything from a traditional HTTP web request to a timer, or the result of simply uploading a file. Again, event-driven. And next, we have Azure App Services. Okay, so Azure App Services is an HTTP-based service for hosting web applications, REST APIs, and mobile backends. Now, you can develop in your favorite language, whether it's .NET, .NET Core, Java, Ruby, Node.js, PHP, or Python. Applications run and scale with ease on both Windows and Linux-based environments. App Service not only adds the power of Microsoft Azure to your application, such as security, load balancing, auto-scaling, and automated management, but you can also take advantage of its DevOps capabilities, such as continuous deployment from Azure DevOps, GitHub, Docker Hub, and other sources, right? You have package management, staging environments, custom domain, and TLS and SSL certificates. With App Service, you pay for the Azure compute resources you use, and the compute resources you use are determined by the app service plan that you run your apps on. There are a couple of types of app services, and those are web apps, API apps, web jobs, and mobile apps.
When we come back from the break, we'll start off with our next lesson.
Welcome back. In this section, we'll be going over networking inside of Azure. We'll go over virtual networking, virtual private network gateways, also known as a VNet. We'll talk about Azure Express Route, which is a fun way to connect. And then finally, Azure DNS. Now, what I want you to take away from this class is that the Azure Virtual Network, or the VNet, this is what allows our resources in Azure to communicate with one another. It's a communication and isolation boundary now by default. So as we look at our outline, this is what we'll be talking about. But more importantly, just by being in the same subscription in our networking, right? The resource, group, or region, resources like virtual machines, for example, cannot communicate by default. And the only way for resources to communicate with one another by default, meaning that you're not making any other administrative changes, is for them to be on the same virtual network. Now, it is possible for resources that aren't on the same virtual network to communicate with one another. But those are going to take additional configuration on the admin side, okay? Now, that's called VNet peering, and that allows you to link virtual networks together to enable resources to communicate with one another. And technically, you can also have resources communicate securely through a virtual network service endpoint. And service endpoints allow you to secure critical Azure service resources to only a virtual network. But for this class, I want you to focus on, what I want you to remember, is that the Azure Virtual Network is a communication and isolation boundary in between your resources. And it's not just the resources that you have inside of Azure. Because especially as we think back to our hybrid example that we discussed earlier, remember, you're leveraging both the public and the private cloud. And you need to have a way for those different services, applications, and resources to, communicate with one another. Well, in order to do that, you need options. Now, we have a couple of different options. Specifically, we're going to talk about two of them today. But before we do, let's actually go into the portal and configure some network access.
In this demonstration, we're going to configure our network access. So let's look at this virtual machine here. We have a virtual machine, and what we are going to try to do is connect to it via RDP. So let's look at our networking tab first. As you can see right now, we have a couple of different rules. Let's go back to the overview and try to connect to it through RDP. So I'm going to go ahead and download that RDP file and try to connect to it directly. Let's click connect and see what happens. Oh no! My remote desktop connection did not work. Now it's giving me a couple of reasons. It's saying the remote access to the server may not be enabled, the remote computer may be turned off, or the remote computer may not be available on the network. So let's make sure first that this virtual machine is up and running. Well, look at that. It is running currently. So let's go back to our networking. Okay, let's look at our network security group, our NSG. And lo and behold, would you believe it? The RDP is not enabled. We need to enable 3389. So let's go ahead and add our inbound port rule. Right here, you can see you have plenty of sources, right? You have your IP address, my IP address, service tag. We're going to leave it as any for now. Our source port ranges, our destination, our service, and port ranges, those are all customizable. But right now, the most important thing we want to focus on is what service we want to add. So you have options as HTTP, HTTPS, SSH. We want to add RDP. So as you can see right here, the port range is automatically going to be defaulted to the 3389. Now the most important thing, look at our NSG. Our NSG is organized based off priority.
So we need to make sure we have a lower number, which is going to result in a higher priority. So right now it's at 100, which is just a little bit lower than 65,000. Let's go ahead and add that rule. So right now it's creating that security rule and adding it into our network and onto our virtual machine. Okay, it says it's been successful. So we're going to go ahead and refresh our network and make sure it's there. And look, there it is. Allow any RDP inbound. So now what we're going to do is we're going to go back to overview and we're going to try to connect one more time. So let me download the RDP file again and I'm going to click open file. Okay. So right there, just like before, we had our Azure user, which is our username, and we have to go ahead and enter our password. Well, now that we opened that port, it's going to ask us again to approve. We're going to click approve those certificates. And look at that. Now it worked. Why? Because we opened those ports. If we hadn't done that, then it wouldn't have been able to connect. And that's how you configure your network access.
So now that we're back from the demo, let's talk about those two. Now the first one is going to be a virtual private network gateway. Now many of you are thinking, what is that? Well, it's commonly referred to as a VPN. Now, this is creating a secure connection between your Azure environment and your on-premises environment. But the key thing here is that you are connecting to Azure, okay, from your on-premises environment over the public internet. Again, the public internet. And some of you work at home now, some of you have worked at home in the past. Well, when you did, or even now, you had to connect to some type of VPN while you were working from home. And what that's doing is it's establishing a secure connection that allows you to access your corporate documents or even your corporate applications. And it works the same way in Azure. However, let's say, for example, you're working with highly confidential and business critical applications. And you can't have them exposed to the public internet because while a VPN is secure, because it is, and it works for most business cases, technically, yeah, there is still some security risk. And does it mean don't use a VPN? Absolutely not, okay? There are tons of cases and many companies use VPNs. However, there are also cases where you need an extremely secure connection. And that could be due to a number of potential reasons, right? And that is where Azure Express Route comes in. What Azure Express Route does is it actually physically connects your on-premises environment with Azure. And the way that that works is we use a third-party connection provider, and we're actually leveraging their cabling. So yes, there is an actual cable connecting to your on-premises that then streams into the Azure network. And this is how you're getting a physical, private connection. So again, you don't have any type of external exposure to the public internet. Azure Express Route is a secure, physical, private connection where the virtual private network gateway is a VPN. That's just a private connection, but it's done over the public internet. VPNs are still secure, okay? But Azure Express Route is significantly more secure because it's a private connection. Now, yes, it is more expensive than a VPN. And most organizations that we work with, VPN is just fine with them. However, if you do have business critical or highly confidential services, Azure Express Route might be a good option for you. So I recommend that, if you think it is, look into it. Because at the end of the day, what Azure Network Services are, is they are allowing communication to and from all your Azure resources.
And later on, when we look at security, we'll actually talk about ways that we can protect them. But first, let's talk about Azure DNS. Think about what DNS is. DNS, or Domain Name System, can be described as kind of like a phone book, okay? It's translating human-readable names to computer-friendly addresses. And Azure DNS, or Azure Domain Name System, is a hosting service for DNS domains that provides name resolution by using Microsoft Azure infrastructure. And by hosting your domains in Azure, you can manage your DNS records by using the same credentials, the same APIs, tools, and billing as your other Azure services. So think back to our first lesson, right? That reliability benefit. If we think about reliability under the scope of the Azure DNS service, well, DNS domains in Azure DNS are hosted on Azure's global network of DNS name servers. And each DNS query is answered by the closest available DNS server to provide fast performance and high availability for your domain. That's reliability. Now, you can't use Azure DNS to buy a domain name, but for an annual fee, you can buy a domain name by using App Service Domains or a third-party domain name registrar. Your domains can then be hosted in Azure DNS for record management. And Azure DNS can manage DNS records for your Azure services and provide DNS for your external resources as well. Azure DNS is integrated in the Azure portal and uses the same credentials, support contract, and billing again as your other Azure services. And Azure DNS truly provides that reliability through its global network of DNS name servers, security through Azure Resource Manager, ease of use and customizable virtual networks through the Azure portal, and alias records. Thank you so much for joining us for this session. I'll see you soon.